Hello, welcome to today's lecture. So we are on chapter 5. We're going to talk about polynomials. For those of you who are following the note on Pearson, we are actually on page 299 on Pearson. Very well. So let us define polynomials in general and actually go over their properties. What is a polynomial? Remember that last lectures we talked about terms, and we say that let us add, multiply, subtract, do some algebra in between each term or a collection of terms. By doing so, we can actually form polynomial. Definition of a polynomial. So a polynomial is a finite. So you have finite numbers of terms that are added or subtracted. For example, here you have 3x squared plus 2x, 3x squared plus 2x plus 6. This is an example of a polynomial. How many terms do we have? Let us count them. We have our first term. Then we have our second term. And here we have our last term, the third term. One thing that I want you to note is about the exponents in each term. Recall that when you have a constant like 6, it means that it was multiplied by a variable raised to exponent 0. When you have invisible exponents, it means that it is equal to 1. And for this term, quadratic term, the exponent is equal to 2. Do we see any negative exponents? No. When it comes to polynomials, we don't have negative exponents. So you can write a note here. Polynomials do not have negative exponents. Very well. In this case, for this polynomial, you have 3 terms. Also note that your very first term has exponent 2. It means that the degree of this polynomial is equal to 2. So we're using each of these terms one by one, and we try to derive some properties for our polynomial. What is important here? Our term with the highest exponent is very important for us. So we can say that the degree of a polynomial is the exponent, the power. Which one? The highest is the highest exponent or power in the polynomial. Very well. In this case, you can write down the degree is equal to the highest exponent, the highest power. In this case is 2. So the degree in that previous example is equal to 2. Very well. 3 in the leading term is called the leading coefficient. First of all, why we call this the leading term? Because this is the term with highest exponent. So we can write it this way. The leading term is the term 3 times x to the second power. And the leading coefficient is equal to 3. So these are the information that we can derive by looking at one polynomial. Let's take a look at another polynomial. Two x to the fifth minus 3x squared plus 6x minus 9. Again, let's take a look at addends or terms in this case. First of all, you have 2x to the fifth plus minus 3x squared plus 6x plus constant minus 9. Very well. What do we see here? What is the leading term? What is the degree of this polynomial? And what is the leading coefficient? Well, the degree of the polynomial is the degree of term with the highest exponent. So again, the constant term is -9 times x to 0. Invisible exponent is 1, then you have 2. You also have exponent 5. So the degree of your polynomial is equal to 5. What would be your leading term? The leading term is 2x to the fifth. And the leading coefficient, which is the coefficient in the leading term, is nothing but 2. So our polynomial has degree 5. We can actually classify different types of polynomials. So if you have a polynomial with only one term, we call it monomial. Mono 1. What is a monomial? A monomial is actually one term. So we can include just a term with degree 5, just a term with degree 3, just a constant term, 5x squared, or x, or just a constant like 1. These are all examples of monomials. As you guess, if we add 2 terms, we get by 2 binomial. So a binomial has 2 addends, or we can say that it has 2 terms attached together by addition or subtraction. For example, if I take 5x squared and 1, I'm actually forming a binomial. 2 addends, 2 terms. Or I can just easily say x and 1, and I can form another binomial. As you guessed, if I add 3 terms, I get a trinomial. a trinomial. A trinomial has 3 addends. So here, if I add these 3 terms, 5x squared plus x plus 1, I'm actually creating a trinomial. If I have more than 3 terms, I in general call it is a polynomial. Many terms and addends are attached together, and I have a polynomial. We can also classify our polynomials based on the degree of the polynomial. So we can also classify our polynomials based on the degree. What do I mean by that? Consider a line or just a constant. We say that if the degree of a polynomial is 0 or 1, then we have a linear polynomial. If the degree of the polynomial is 0, like what? Like a constant, or 1, like what? Like just a variable like x, then we call it a linear expression. Very well. If the degree is equal to 2, we call it a quadratic expression. Quadratic. If the degree of the polynomial is 2. We say we have a cubic expression if the degree is equal to 3. So cubic if the degree of the polynomial of the expression is 3. So classification based on the degree. In other cases, we look at the highest exponents, and we say that the degree of the polynomial is 4, or if it's 5, we say that the degree is 5, and so on. Well, when it comes to polynomials, you need to know that polynomials are functions. What do we mean by that? It means that they have domain and they have range, and you can graph the polynomial using either a graphing paper or an online websites like Desmos, GeoGebra, and actually visualize the polynomial. And at the same time, you can evaluate your polynomial. So note that polynomials are functions. We usually denote a polynomial by p of x. example, suppose you have the following polynomial function. This function is 7x minus 3 plus 6x squared. Very well. First of all, you can write this polynomial function using standard form. It means that first we write the leading term, then the linear term, then we write the constant. In that case, you have p of x equals to 6x squared, the term with highest exponent, plus 7x, the linear term, minus 3. We can visualize the graph of this polynomial. We're going to take a look at Desmos and actually see the graph of this polynomial, which in this case, we call it a parabola. Let us take a look at Desmos. Here we have 6x squared plus 7x minus 3. Very well. As you can see, the graph opens up and we call it a parabola. Well, another polynomial for you. Suppose you have p of x equals to 4x cubed minus 6x squared minus 2x plus 9. First of all, what is the degree of this polynomial? The degree of your polynomial is the degree or the exponent or the power of the term with highest exponent, highest power, which is 3. It means that we have a cubic expression. It is a function, px is a polynomial function, or you can say that it is just a function with degree equals to 3. Now the question says evaluate the polynomial function at the given points. So suppose the first value, the first x value is 0. What is your y value? What is the value of your function? B. Now suppose your x is equal to minus 2. What is your y value? Note that in each cases, x is given. You're looking for the second coordinate or y coordinate. Very well. To evaluate the function, we substitute 0 wherever we see x. So p of 0 is equal to, we write down the equality. The first value we see is 4. Next, we have x raised to 3. It means that we have 0 raised to the third power. We copy down minus 6. Here you have x squared, so 0 squared minus, we copy down 2 times 0 plus 9. Very well. 0 raised to 3, it's not 3. It is 0 times 0 times 0, which is equal to 0. 4 times 0 is actually 0. Minus 0 raised to 2, it's not 2, it's 0 times 0, which is 0. 0 times 6 is 0. 2 times 0 is 0, and we have the constant 9. 0 minus 0 is 0, 0 minus 0 is 0, 0 plus 9 is equal to 9. This is your y value. So what's the meaning of this? It means that points 0 and 9 is on the graph of the function. How about the second one? Minus 2 is your x value. Wherever you see x, you plug in negative 2. Very well. So here you have 4 times minus 2 raised to the third power minus 6 times minus 2 raised to 2 minus 2 times negative 2 plus 9. Very well. Negative 3 raised to 3. It is not negative 6. It is negative 2 times negative 2 times negative 2. You have 3 negative signs. The outcome is going to be negative. 2 times 2 is 4. 4 times 2 is 8. So here you have 4 times negative 8 minus negative 2 times negative 2. It's going to be positive 4 minus 2 times minus 2 plus 4 plus 9. Very well. 4 times negative 8, negative 32 minus 24 plus 9 plus 4 plus 9. Very well. Here you can say that negative 24 plus 4 is actually minus 20. Minus 20 plus 9, it gives me negative 11. Negative 11 minus 32, the final answer is negative 40. Again, you have your y value. So what's the meaning of that? It means that point negative 2 and negative 43 is on the graph of this function. Point negative 2, negative 43 is on the graph of the function. Let us take a look at our Desmos. Actually graph this polynomial. We have 4x cubed minus 6x squared minus 2x plus 9. Very well. Here we have the graph of this polynomial function. If x is equal to 0, when x is equal to 0, you get this point on the graph of the function. As you can see, when x is 0, your y value is 9. What if your x is negative 2? If x is negative 2, we're looking at minus 2 as our x value. Let us go further down to find the y value. Very well. Minus 2 and negative 43. This is a point on the graph of your polynomial function. Very well. Now I expect you to ask You define some new functions, polynomial functions. What operations I have to actually connect these functions and create a new function? Very well. Like before that we defined operations between functions, since polynomials are just another example of functions, you can apply all the operations that you had for any regular function like addition, subtraction, division, multiplication, and composition. You can apply all of them here. So this is our goal now. Our goal is to combine polynomials and actually create a new polynomial. So this is our goal, to combine polynomials. What operations? We can apply all those operations that we learned before. As usual, we're going to start by adding functions, adding polynomials. Operation, addition. Let's take a look at this example. Suppose we want to add the following polynomials. So here you have 4x squared minus 6x plus 8 plus 2x squared plus 5x minus 1. Very well. Remember that. You have to add like terms. If you have subtraction, you can subtract like terms. So when it comes to adding, subtracting, we have to look for like terms. What are like terms? Like terms are the terms with the exact same variable and the same exponent. So first, identify like terms. 4x squared, 2x squared. So by adding 4 and 2, we get 6x squared. Next, 6x and 5x. And note that you have a negative next to your 6. So this is negative 6 plus 5, which gives you negative 1x. And finally, 8 minus 1, which is 7. Remember that for simplicity, 1 times x can be written as just x. So this is equal to 6x squared minus x plus 7. Another example for you. Suppose this example says subtract. So we are moving on, subtracting. Please be careful. Example says subtract this polynomial, negative x squared minus 2x plus 11 from x cubed plus 4x plus 6. So which one comes first? Which one comes second? We are subtracting this polynomial from this polynomial. So the second polynomial comes first. It's going to be x cubed plus 4x plus 6 minus, let us put the polynomial into parentheses. Why is that? Because we have to distribute the minus sign into the parentheses. It will change all of the signs in this polynomial or in this expression. Here we have minus x squared minus 2x plus 11. Well, let us distribute the negative sign into parentheses. Then we look for like terms. This is equal to, we copy down the first term, we copy down the second term, we copy down the third term, minus times minus, two negative signs, gives you plus x squared minus times minus plus 2x minus times plus minus 11. Very well. Now we're looking for like terms. Do you have any term other than x cubed with degree or exponent 3? I don't see any. So I'm going to copy this term down, x cubed. I have 4x and 2x. These two are like terms. 4 plus 2 is 6x. I have 6 and minus 11. 6 minus 11 gives you a negative number, minus 5. And finally, I left with plus x squared. This is subtraction. There you go. Our last example in 5.1 is actually asking to find a perimeter or surrounding of a shape of an object. Example says, find the surroundings or perimeter of fix this perimeter of the following object. So all sides are given, 3x plus 2 as expressions, x squared plus 1, x squared plus 2x plus 3, and finally 5x plus 3. Very well. The definition of perimeter or the surrounding, it means that you have to add all sides together, and in this case, if you can simplify that, we're going to do the same. So to find the perimeter, we need to add all sides, then simplify. So how do you add all sides? The first side, 3x plus 2 plus the second side, x squared plus 1. The third side, it is x squared plus 2x plus 3. And the last side is 5x plus 3. Well, let us simplify this. We have 3x plus 2x, so 5x so far, plus 5x, we have 10x. We have 2 plus 1, 3, plus 3, 6, plus 3, 9. And we also have x squared plus another x squared, 2x squared. So 2x squared plus 10x plus 9 is the expression actually representing the surrounding or the perimeter of this object.